Good afternoon, everybody. I think I'll get started. Guess what? It's not sunny in here, so I don't need these. Yes, I'm alive. By the way, first of all, let's get started and then I'll tell you about my second cataract operation. Good afternoon, everybody. Welcome to an overcast, sort of cold, but wonderful afternoon of Chem 170 with your host, me, Dr. White. And as you know, on Monday, I had cataract surgery on this eye. And my ophthalmologist, eye surgeon, Dr. Cabin, was fantastic. So were all the people at the Hoffman Estates Surgical Center, the nurses and everybody, fantastic. I only wish before I had both of these done, I knew what I now know about my eye surgeon, Dr. Cabin, because if I knew that before I had this first eye done, I wouldn't have wasted all the worry and anxiety I put myself through, because Dr. Cabin is fantastic. If you know anybody who needs cataract surgery, lives in northwest suburbs, you want to go to Dr. Cabin. If you need his information, email me. He's Dr. Cabin in Hoffman Estates on Barrington near Golf, and did a fantastic job. Fantastic doctor, answered all my questions. Just an awesome person, and even better, a fantastic surgeon. So this eye's doing pretty good. If you look at my face, this is the first time in 50 years I haven't worn my glasses. Yeah, 50 years I've been wearing them that long, and it's amazing. All right, let's get on with school, because you didn't come here to learn about my eye surgery. Maybe you did, but all right. After class today, about 2:15, probably earlier than I had my email, I will send out to all of you an email with the password for test number 4, which you will take today, and you'll have until 11 tomorrow to take it and upload your answers as a single PDF file to Blackboard, wrong school, D2L, wrong school, to D2L, Desire to Learn. And I guarantee, probably a lot earlier, but I guarantee by Sunday, 1 p.m., I'll have all your scores, your grades in D2L. And also I will send out individual email to each of you with how many points you obtained or were given or got for each question or answer you put down on test number 4. Now, what I'd like to do today, excuse me, is a couple things. First of all, I like to go through the review again. I think it'll help. I know all of you, at least I hope you all did, watch the video on Monday that I posted. Actually, I probably posted it earlier Sunday, but for Monday's class that we missed, I missed, you didn't if you watched the video, but this might help you a little more. Also, if we have time, which I think we will, I'll go through again the new stuff that won't be on test 4, but a couple points will be on the finals dealing with proteins and amino acids. And then we'll do the last lab of the semester, carbohydrates, which really should be named starches. And with that, let's get started. All right, everybody see test number 4 review? It looks like deja vu. Trust me, this will help you later today. Don't tell anybody I'm being nice. Shh. Okay. All right. First of all, you should know what a polymer is. A polymer is a macromolecule. Another way of saying that it's a big molecule made up of repeating units called monomers. Now, there are 2 types of chemical ways of distinguishing polymers. One is by chemical property. The other is by a key physical property. And you should know addition polymers have only one type of monomer used. An example would be saran wrap or car tires. I guess you could also do bicycle tires too. Now, condensation polymer is a polymer with two or more different types of monomers used to make that polymer. And my plastic water bottle, a polyester is that. So is if you have a nylon jacket on. I don't, but if I did. Now, the other type of property, the physical property, there are two types you should know. Thermoplastic, that's once a polymer is formed, it can be reheated and reshaped to form a new polymer what shape. An example of my plastic water bottle, or I think nylon is also thermoplastic. But the other type is thermoset. Once formed, whatever object you're making with that polymer, it cannot be reheated and reshaped. An example of that would be car tires or bicycle tires, rubber products, or urethane foam. Next, I talked about fats and oils. And the first thing you should know is a lipid is a molecule that comes from a plant or animal that's soluble in non-polar solvents, but not soluble in water. Now, there are two types of lipids, a saponifiable lipid and a non-saponifiable. And the saponifiable is determined by the fact that yields carboxylate anions of fatty acids in the reaction of base and water, also known as under alkaline conditions, which I would never do. And what really is a saponifiable lipid? Of fat and oil. And what's the key functional group in a saponifiable lipid? Fat or oil? Ester. Now, the non-saponifiable lipids don't react with base and water. And I taught you those are our steroids hormones. Now, what's the fat? You should know that's a solid or semi-solid triglyceride, or you could also put down triester at room temperature. Oh, I forgot to cross the T there. Oil is a liquid triglyceride, or you could also put triester at room temperature. Oh, I crossed the T in that one. Now, fat and oil has this general structure, and they're just three esters in the same molecule, and each ester reacts like it was alone. If you take an ester and react it with acid and water, you learn for test 3, get an alcohol and the carboxylic acid you would have used to make that ester. Now here, if you take a triglyceride and add acid and water, you'll get glycerin and each of the carboxylic acids that you get from the triglyceride, fat or oil. And for base, if you take a ester base, and I'll use sodium hydroxide and water, you get the alcohol, but now you get the carboxylate anion of the carboxylic acid you would have used to make that ester. So if I have this triglyceride, I'll get glycerin. Each ester will give this alcohol together as glycerin. This first ester will give this carboxylate anion. The second ester, this one. Third, this one. Now, I taught you, and this is something I used when I was in industry, a company I worked for, we used to make fatty acids and glycerin. You take an ester and react it with steam, which is hot water, and by heating it, you don't need a catalyst. There are two ways to make a reaction go faster. One is use a catalyst like acid or base, which I just showed you. The other is run it at a higher temperature. And hot water, steam will do that. And when you do a ester, you'll get back the alcohol and the carboxylic acid you would have used to make that ester. So if I take my triglyceride, steam, hot water, you will get these three alcohols together as glycerin. This will give you this carboxylic acid. This ester will give you this one. This ester will give you this one. Now, these carboxylic acids that you get from triglycerides are called fatty acids. And I asked you to learn the structure of only 2 fatty acids because they're key ones used in our daily life. The first one is stearic acid, which is a saturated fatty acid. There's only carbon-carbon single bonds, and it has 18 carbons, CH3, CH2 16 times, and here my carboxylic acid. Now, oleic acid is a monounsaturated. Mono means one. Unsaturated means it's got a double bond. Mother Nature never did triple bonds. Organic chemists did that, but not Mother Nature. And here we have also 18 carbons, but notice at carbon 9, I have a double bond. So I have CH3, 7 CH2s, my double bond, again, 7 CH2s, and my carboxylic acid. And you should know this. Now, saturated fat, you should know, has only, and it's important to say, carbon-carbon single bonds, because there is a carbon-oxygen double bond, so you just can't say it only has single bonds. You have to say carbon-carbon single bonds. Unsaturated, just like unsaturated hydrocarbon, there's at least one carbon-carbon double bond present. Saturated, only carbon-carbon single bonds. Unsaturated fat, at least one carbon-carbon double bond. Now, since I worked in this industry, I expect you to know that tallow is beef fat and white grease and yellow grease are 2 different types of pig's fat. And nobody uses lard and trying to think what beef fat is called, the other suet or something like that. No, in the chemical industry, it's tallow, beef fat, white grease, yellow grease, pig's fat. All right, now, since I worked in this industry, I taught you could use this representation of this triglyceride for either tallow, white grease, or yellow grease. And R sub S means this ester would give you stearic acid. R sub O, this ester would give you oleic acid plus glycerin you're going to get. And the final one, this ester would give you, again, stearic acid. And notice my joke, SOS. And on a test, if I ask you give the structure of stearic and oleic acid, use these. But if I give a name or this, you can use the abbreviation R sub S, R sub O. So if I ask you tallow, sodium hydroxide, and water, and you get 3 products, is really asking you this ester, because for tallow, white grease, or yellow grease, you will use this representation, ester-based alcohol plus the carboxylate anion of the carboxylic acid you would have used to make that ester. Therefore, first ester, I'll get this alcohol plus sodium stearate. Second ester, I'll get this alcohol plus this is sodium oleate, this carboxylate anion. And the third ester, I'll get this alcohol, but I'll get another one of these sodium stearate. Now, do you have to put the 2 there? No, because I'm just asking what are the products. And the individual products, 3 of them, glycerin, sodium stearate, sodium oleate. And you should know how to do this with HCl and steam. The only difference, instead of getting the carboxylate anion for these 2, you'll get the carboxylic acid. Now, there's something that's very important that I expect you to know leaving my class. How does soap work? And you should know the structure of soap is a nonpolar tail, polar head. And you should know water is polar and dirt and grease, or just dirt, is nonpolar. And the most important thing, the most important thing, am I being obvious or what? Is light dissolves light. And when the dirt particle, and you wash your hands or whatever with soap and water, the dirt is nonpolar which will attract the nonpolar tail of the soap because of light dissolves light. The polar head will want to stay on the outside far away because light dissolves light. And you should know this is a micelle. And now the micelle, when water looks at it, only sees the outside polar heads and says, oh, micelle, I'm polar, you're polar. We know light dissolves light. That's the important part of the puzzle. So let's go down the drain together. And they do. Now, when it comes to the non-saponifiable lipid steroids, the only thing I'm asking you to learn is how to draw the ring skeleton for any hormone or steroid. That's a 6-membered ring, 6-member ring. Up on top here, a 6-member ring, and next door, a 5-member ring. And it's all fused together. Again, you should know how to draw this basic ring skeleton 6665. Next, I talked about carbohydrates. And carbohydrates are polyhydroxyl aldehydes or polyhydroxyl ketones or molecules that upon hydrolysis becomes a polyhydroxyl aldehyde or ketone. Now, I talked about chirality, and you should know the word chirality, or chiral really, means handedness. I'm glad they didn't pick footedness. That wouldn't sound good. But anyways, and you should know what's a chiral object and what's an achiral object and how to identify things. A chiral object is an object with a non-superimposable mirror image, like your hands. They're mirror images, but they're not superimposable. Same thing with your feet and your face. Chiral object, remember I drew a needle, sewing needle, would be superimposable. And you should be able to identify if a, hold on one sec. I have to put eye drops in sometimes during my eyelashes. I got to be very careful when I touch this eye to make sure I don't touch the lens they put in. I've been good about that. Plus, I have to wear a shield on this side. I did for 2 weeks on this side at night. Not fun, but it's important. All right. You should be able to know what's chiral and achiral. And if it says right or left in the name, it's always going to be chiral. I'll say that again. If it says right or left in the name, it will always be chiral. Now, chiral carbon is a carbon in a molecule that has 4 different groups or 4 different atoms or a combination of 4 different groups or atoms. And on the Monday video, I went through that, but let's do something real quick. Why don't you circle the chiral carbons in that molecule? And when you're done, give me the, thumbs up. Thank you. All right. Now, what's a chiral carbon? It's a carbon that has 4 different atoms, 4 different groups, or a combination of 4 different groups and atoms. So if you have two or more of the same atom on a carbon, it can't be chiral. So that's out, that's out, that's out. If a carbon is in a double or triple bond, it can't have four different groups. So this is out, and this is out. So this leaves us this one and this one. Now, let's look at this carbon. Has a hydrogen hydroxy group, a methyl group, and then all of this I'll call R. So it's 1, 2, 3, 4 different things. If we look at this carbon right here, as an iodine, hydrogen, and now this is one group I'll call R attached to this carbon. And this is another group which is different. I'll call R prime. And if we look at that carbon, has iodine, oops, let me get my pen back, iodine, a hydrogen, R, and R prime, 4 different things. And that's how you circle the chiral carbons, which is a skill you should have. Next, I talked about enantiomers. And enantiomers are molecules that have non-superimposable mirror images. So if I were to ask you, draw the enantiomer of this molecule, why don't you try, and then I'll draw the mirror image. Because when you see the word enantiomer, that means the mirror image, non-superimposable. By the way, I would never trick someone on a test by putting a molecule that doesn't have a non-superimposable mirror image when I ask you to draw the enantiomer, because that wouldn't be fair, and that's not something I would do. And it violates my golden rule of teaching. Don't do to my students what I wouldn't want done to me. I sure wouldn't want that on a test. That's not fair. Thank you, Megan. Thank you, Joe. So you don't have to, but somewhere along the line, I got in the habit of drawing in my mirror. Again, you don't have to. And my reflection, since this is an achiral carbon, 2 hydrogens, you can draw it like this. If you wanted to draw it like this, that would have been okay, but this is okay. And this carbon, which is a carbonyl, remember, it really means this, has a double bond, so it's achiral. You could draw it this way. If you wanted to draw it this way, I'd smile, but that's okay. But now let's look at the next, this one here. What's closest to the mirror, you'll see in the reflection. What's farthest away will be farthest away in the reflection. Same thing here. What's closest, you'll see what's farthest away will be farthest away. And the same thing for this one. And let's call this A or B. Either one would be correct on the test. So enantiomer means draw the mirror image. Now, next I showed you how glucose, which has an aldehyde up here, this hydroxyl group can react with the aldehyde intramolecular reaction. That means all in the same molecule, forming, in this case, glucose, a hemiacetal, this reaction. And you don't need the acid catalyst because it's in the same molecule. And therefore, you should know for this equilibrium how to do this product or write this starting material. And for fructose, which is a ketone, same thing happens with C5 hydroxyl, second to last one, same reaction, but now you get a hemiketal, and this you should know. Again, glucose is the aldehyde you start with, fructose is the ketone. Now, once you have a hemiacetal or ketal, what I didn't teach in test number 2, you can react it instead of with a second molecule of the same alcohol, a different alcohol and acid to form the unsymmetrical acetal or ketal. And in general, the reaction with glucose and alcohol gives you this acetal, and this is important, how you link glucose together to make starch. And some things about that, you should know sucrose, table sugar, is fructose and glucose bonded together. You should know sucrose is fructose and glucose bond together. Starch is polyglucose, a polymer glucose, a lot of glucose molecules linked together, like a freight train. And therefore, if I take 50 glucose molecules, hit it with some acid, you'll get starch, which we'll talk about. And the linkage is an acetal or ketal, which we learn from test number 2. If you react it with acid and water, you'll get back to starting alcohol, ketone, or aldehyde. So sucrose in your stomach, acid and water. I could have also put HCl, because that's the H plus in your stomach, gives you glucose and fructose. You should know that. Starch, acid and water, gives you glucose. It breaks it down again, back to some individual glucose. And you should know that. Now, key, leaving my class, you should know, really know, how to describe with words in a general reaction what happens when you eat something with a fat or oil in there. What's the key functional group in a fat or oil? An ester. What's in your stomach? Acid and water. So therefore, it's acid hydrolysis of an ester. And from test 3, here's the general reaction. Ester plus acid and water give a carboxylic acid and the alcohol you would have used to make that ester. Now, the other thing I asked you to learn was, and sort of, this should go away at the bottom in a second, I hope. Or maybe it's not, but yes, it did. All right, when you eat a carbohydrate, what's the key functional group holding glucose molecules together? An acetal linkage. And in your stomach, there's acid and water. So it's acid hydrolysis of an acetal. And for test number 2, if you take an acetal and acid and water, the very bottom of the page, and H plus could also be HCl, you get back the aldehyde or ketone you would have used to make that acetal plus the alcohol. And that's all you have to know for test number 4. Any questions? And by the way, these are going good, thanks to Dr. Cabin. God bless him. Am I happy? Am I relieved? By the way, yesterday and Monday afternoon when I got home, this was my vision out of here was really foggy. I didn't drive. A friend of my best friend took me home. And then yesterday, it was still sort of foggy. Yesterday afternoon, I had an appointment with Dr. Cabin, and now it's a lot better. You see? All right. How are we doing time-wise? First of all, and if you have any questions, remember, it's always true. There's no such thing as a dumb question. Ooh, speaking about that, next week is our last week really together, I think. Well, I have to look into the syllabus, but probably Monday at the end of class, and I'll put out an email to this effect, but I will cut it out of the video. I started doing this a couple of years ago when I realized it could help students. In my position as a senior R&D manager in a couple of different chemical companies, international chemical companies. One, I interviewed for very high-level jobs, and two, at those companies, I hired people, so I had to interview people. And what I started doing a couple of years ago that was really helpful to my students, and I'll tell the story how helpful next week at the end of lecture. I'll end a little early, but I'll cut it out of the video so I can teach you this. I'll give you some important tips how to interview. And all of you, if you're going into any kind of profession, if you're trying to get into school or nursing or stuff like that, you're going to need to be interviewed like nursing school. Or if you're trying to get a full-time job, which I think all of you want to, you're going to have to be interviewed. And I can give you some really important tips that work really good. It's worked for me. It's worked for my students. All right, something I want to cover right now, which was in the video, but I'm just going to hit some highlights. All right, everybody see chapter 17 on your screen. Thank you, Megan. All right, you should know what is an amino acid. And an amino acid is a carboxylic acid that has an amine group. The full name is amino carboxylic acid. But organic chemists are lazy, so we just call it an amino acid. And the important thing to know here, this will be on the final couple of points, not on test 4, but another way of writing it. And you learn from ketones and aldehydes, the carbon attached to the carbonyl carbon is the alpha carbon, and in all amino acids, the alpha carbon has the NH2 group. And R can be a lot of things. Now, it turns out that the alpha carbon of certain amino acids, well, first of all, it's bond, when the alpha carbon is bonded to 4 different groups, that carbon is chiral, which makes most, but not all amino acids chiral. The one exception is when R is a hydrogen. So if we think of this, when R is not hydrogen, because then you'd have 2 hydrogens on the alpha carbon, these are chiral. An example would be something like this. If I were to ask, draw a chiral amino acid, this would be an example, because the alpha carbon has 1, 2, 3, 4 different groups. So you know that's a chiral carbon, which means amino acids can do, you can have the different enantiomeric forms itself or its mirror image. Now, I talked about zwitterion. Zwitter, by the way, having learned German in high school and college, and also for my PhD exam or degree, part of the PhD program at Michigan State. I don't know if they still do it, but you have to pass a foreign scientific language proficiency test. and mine was German. I had to translate 25 pages from technical journals with less than, I think it was 5 mistakes. You hand that in, then they gave you a journal article and you had to translate it. You could use a dictionary, but still 2 pages. And you had to have, I think, 5 or less. First time I took it, I failed it. Second time I took it, I practiced more and I passed it. And if you don't pass that test, just pass, fail, you don't get your PhD. So zwitterion, why am I pronouncing that V like a W? Because that's how Germans pronounce a W, or German language. And zwitter comes from the German zwei, which means two ions. And in real life, this equilibrium can exist at pH 7. It exists in the zwitterion, but that won't be on the test. But you should know you can form an amide linkage. This in red, carboxylic acid, this amine makes this amide. And notice how I've linked 2 amino acids together. They can be the same or different. In this case, they're the same. I still have on this end an amine group. This has a carboxylic acid, so I can link more amino acids together. And when you do, you form what protein chemists call a peptide bond, but synthetic organic chemists like me call it an amide bond. And what I will never ask, but protein chemists call peptide 2 or more amino acids linked together by an amide bond, which they call peptide. I like calling amide. And I'll never ask that on tests. A protein is when you have 50 or more amino acids connect together with amide bonds, peptides. Now, you should know, and I'll write it down, what happens in your stomach when you consume a protein. Well, what's in your stomach? Hydrochloric acid and water. What's the key functional group holding amino acids together? That's an amide. And the general reaction that you learned for test number 3 is amide, HCl, and water. You get back the carboxylic acid you would have used plus the amine salt. Another way of writing this amine salt I could have done. These are the same, just different ways of writing it. Organic chemists are lazy. Usually the top way is quicker. That's why we do it that way. And as you can see, if you take a peptide, or if this was even longer, it breaks it down. Now, this amine in the presence of HCl will give you an amine salt. And this one, as you learn, the amine becomes amine salt. And Mother Nature has provided a way in our stomach to make amine salts of the amino acids, which makes them more water soluble and useful to be transferred in your blood. And now, this won't be on test number 4, but for the final, you should know how to describe with words and a general reaction what happens when you eat a protein. And what's in your stomach? Acid, HCl, water, so it's hydrolysis. What's the key functional group in a protein? An amide. That's what holds the amino acids together. So it's acid hydrolysis of an amide. And for test number 3, you learn the following. If you take an amide and react it with the acid, HCl in your stomach and water, you'll get back the carboxylic acid plus the amine salt of the amine that would have been used to make that amide. And it turns out in an amino acid, these are disconnect together, but you don't have to put that there. But you should know this general reaction. What happens when you eat a protein? You should know how to describe with words. That's acid hydrolysis of an amide. And for test 2, you learned the general reaction is an amide, acid, and water. You get a carboxylic acid and the amine salt of the amine you would have used to make that amide. All right, next, maybe Wednesday, and I'll have to put out an email. I'm going to do something I'm definitely going to cut out of the video because I have to for security reasons, but I will do on Zoom, I will take you on a tour of a real chemical plant. Next Wednesday, I'll take you on a tour of a real chemical plant. Also next week, which will help immensely, I've gotten feedback from students over the years that it has. I will do a review for the whole semester. Again, I'll do Monday and Wednesday a review for the whole semester. So definitely show up. With that, let's take a 5-minute break. We'll do the lab. We'll finish up. I'll let you go and I'll send out. Notice I have a note to remind me, send an email out. I do that with a Post-it just so I don't forget. And let's take a 5-minute break. Come back at 1:48, 1:48, about 5 minutes from now. I'm gonna get up and stretch. I'll see you in 5. let's get started. Let me also open up the lab. I don't need this. I don't need this. I look in there and say, oh no, you forgot to put your glasses on. You don't need to, because of the great job Dr. Cabin did. I am so happy and pleased with that. All right, excuse me. Before we do the last lab, I'll wait for Megan to get back. And she's back. Anyways, over the weekend, I will post important information, final exam. Now, when you look at the final exam, you go, oh no, it's 18 pages. Relax. I've been doing that for many years. Students do real good on my final if you practice and go through, show up to my review next week and do some practice problems. Use your hourly exams as practice problems. Will I put the exact same problems? No. Will I put similar ones? Of course. Look at my practice problems we've done all semester. Those have been similar to what you've seen on the 4 tests. And therefore, I'd highly recommend if you can go back and do each test and do the problems on there, or go back and look at the practice problems for each chapter. Either way, you'll do great on my final. Students have. Now, one of the things I will talk about again next week, like I said, I'll post important information, how many points on each test I'll take, and also how many general knowledge, reactions, and nomenclature. And the final will have 10 bonus points. Speaking about 10 bonus points, don't forget, coming up next week is the extra credit project deadline. If you want to do it, email me your project before you upload it to D2L. I'll check it. If there's anything wrong, I'll let you know how to fix it. So that way, if you do any effort, you should be able to get 10 bonus points, which can't hurt. It will only help everybody, but that's your option. Now, one thing I will say about the final, the first part of the final will be from test number 1 material. After that, test number 2, then 3, 4, at the very end, some of the new stuff I just talked about today. So I don't shuffle everything up. I separate it, and maybe that'll help you a little, just a little. All right. And let's talk about today's lab, the last lab. In the last lab, I have labeled carbohydrates. I really should have, is there something on my eyebrow? Oh, it's up here. Excuse me. Hope I'm not grossing anybody out. Be careful. It's from my eye drops. When you're trying to do it, it's hard. It doesn't always go where you want it to. But anyways, today's lab deals really with starches. And let's take a look at it. Don't forget, hand in the lab that's due today. And let's talk about carbohydrates. Now, a lot of my labs I've talked about over the semester, I set up and created to show you before the electronic equipment organic chemists have different instrumentation. We use visual tests, things that change color to help identify things. And one of the classic ones is to find a starch. Now, starch is a cyclical compound or spiral of glucose, even though you see it right, and they're hydroxyl groups from the glucose molecules all along here. Now, someone found out if you took iodine, which is a brown color, and react it with a starch, you get something that's dark blue, so dark you think it's actually black. But if you look at it, it's a very, very dark blue. What happens is the iodine crystals get trapped in here and interact with the hydroxyl groups. And that's why this turns. Now, if you don't have a starch, it stays brown. Well, there's a problem with iodine, I2. It's a solid at room temperature. It's also non-polar. Ooh, you learned about that, which means it's not soluble in water. So what do? Well, someone found that if you react Ki or sodium iodine with iodine, potassium iodine, you get tincture of iodine, which is a mixture of water, alcohol, and Ki3. And let me show you in the whiteboard. And this is something you should remember for this lab. If I take Ki plus iodine, I form this compound, which is really this. A salt. And this is ionic, which means it's now polar and it's water soluble. I assume everybody knows H2O is water. Well, I hope you know. I think I'm spelling soluble wrong. Let's look up. My favorite spell check. I spelled it wrong. I figured it was right. Let me correct that. I was always first one down in spelling bee, and certain words I still am. There, it's water soluble. And this is important because now you can make a solution and just drop a few drops of something on there. And this does the same thing. You have a starch, but you mix it with Ki3, potassium iodide. If there's starch present, guess what? Turns dark blue. So dark, you might even think it's black. And really, you got to look real hard to see it's not black, but really dark, dark blue. Now, if you have something that's no starch in it, and you put a few drops of Ki3 on it, solution, you get no color change. Now, in this lab, you're going to test a bunch of interesting things. And what you'll do, and if we're in a lab, we have, it's about this big, a little glass plate, which is called a crystallization dish. And you put a small amount of each carbohydrate or other things that are not carbohydrates to be tested. And you put a few drops of tincture of iodine on there and you observe it. Now, let's take a look at this video. Give me a second or two or three while I set it up. Let me get rid of this garbage on the screen, turn the speaker off, skip the ad.
An important constituent of our daily food are carbohydrates,
Everybody
which we
see the
consume in the
YouTube?
form of starch. Starch is a high-calorie food that
Thank you.
converts to sugar during digestion. Starch is also produced by all green plants as an energy store. Today, we will conduct an experiment to test the presence of starch in potato, rice, sugar, and salt. For this, we will need iodine solution,
That's tincture of iodine.
which is yellow-brown in color. Note the change in the color of iodine as it is put on the rice and potato. Both turn the iodine blue-black. Put some iodine on the sugar cubes. The color does not change. Salt too does not change its color. This proves that sugar and salt do not contain starch, while the starch in rice and potato reacts with iodine to form a blue-black compound. Now, the reaction is because the blue-black color is basically the formation of polyiodide chains from the reaction of starch and iodine.
Why just brush to clean when you can do more?
Now in this lab, I've already got the results. Does everybody see test results on your screen? Thank you, Megan. And when you use a potato, the solution turns a dark blue or black blue, as he called it. Bread, dark blue. Now, I'll explain yellow and white cheese in a second. I'll come back to that. Flour, dark blue. Cereal, I think it's Cheerios we use, dark blue. Sugar, like you saw in the video, brown. Honey, brown. And cornstarch, dark blue. Now, for whatever reason, I'm not going to go into, for this lab, I've got to bring in the potato, bread, and white and yellow cheese, and flour, and cereal. We've got the other things in the lab. Well, one year, to save money, it was on sale. I bought, the individual wrapped white American cheese at my local supermarket that was off-brand, super cheap. And when the students did the lab, cheese shouldn't have any starch in it. And when they did that yellow cheese, it turned it dark blue. And I said, wait a second. I tried it because I figured they made a mistake. That's the first thing. When you see results you don't like or believe, you try it again. And I got dark blue. Then I read the label of the package and it had starch fillers in it. So next time we did the lab, I went out and bought some more expensive white cheese. I forgot which was, Swiss or something like that, which had no filler in it. And that's why the yellow cheese in this experiment is dark blue It's cheap stuff with starch filler. That's why they can get away selling it so cheap. But the white cheese is more expensive because there's no filler. Now, for this lab, you've got to answer these questions. And if you've been listening or go back and look at the video, you should be able to answer that. And with that, I only have one or two last things I want to say, and I'll say it again on Monday. One, you should have received an email for you to go to do a questionnaire or an evaluation of me. I will not know who does it. I won't even see it until next semester, probably not till January or end of January. It will not affect your grade. So please do your evaluation of me. Now, if you really like what I did, go to ratemyprofessor.com and let people know about that. If you really didn't like what I did, go to ratemyprofessor.com and let people know about this. Now, if you really, really, really like what I did, send an email to the Board of Trustees, Elgin Community College, and let them know you really, really liked what I did. If you really, really didn't like what I did, do the same thing. Send an email to the Board of Trustees at Elgin Community College. If you look on the website of ECC, you can find it. If you need me to give it to you, I can also give it to you. And with that, we're done. In a couple minutes, I'll send out the email for the password for test number 4. You have until tomorrow to 11 o'clock to get it in. Should take you about 40 minutes to finish. If you need more time, I won't take it. And with that, I'd like to talk to Megan for a second. Other than that, I'll say, gang gesund, goodbye. I'll see you next Monday. By Sunday, 1 p.m., if not sooner, I'll have the test scores in D2L. I'll also have emailed out your individual points for each answer on test number 4. And by Sunday, 1 p.m., I'll also have posted important information for the final exam, which I believe is a week from this Monday, is it? Something like that. Wow. And by the way, I haven't done it. Happy December. It's my favorite month. Why? Because at the end of December is my birthday. Oh, by the way, I don't know if I told you, my favorite birthday gift of all time that I like is a mole of pennies. Just pennies, 6.02 times 10 to the 23rd pennies, which is, I figured out, 100 million piles, and each pile has $1 billion in pennies. You can also give me a check. I'll take that too. Kidding. But anyways, with that, gang gesund. Goodbye.